a strange discovery. Astronomers discover clouds of sand in the atmosphere of a failed star. Yet another stunning new first for the James Webb Telescope. This is by Michelle Star Science Alert. New observations from James Webb Space Telescope give us direct confirmation that some alien worlds have clouds of rock. The telescope has directly detected silicate clouds in the atmosphere of a brown dwarf, the first time, according to the international team of astronomers, that such a detection has been made in a planetary mass companion outside of our solar system. The complete findings, the team says, constitute the best spectrum yet for a planetary mass object. These results could not only help us better understand these so-called failed stars, but represent the foretaste of what the James Webb Telescope can do. The paper has been submitted to AAS journals and is available on preprint server ARXIV while it undergoes the peer review and publication process. We've already seen James Webb Telescope take a direct image of an exoplanet, but a brown dwarf is a slightly different kettle of fish. These objects are what happens when a baby star does not accumulate enough mass to kickstart hydrogen fusion in its core, and they occupy the mass regime between the chunkiest planets and the weeniest stars. But around 13.6 times the mass of Jupiter, brown dwarfs can fuse deuterium or heavy hydrogen with a proton and a neutron in the nucleus instead of just a single proton. The fusion pressure and temperature of deuterium are lower than that of hydrogen, which means brown dwarfs are kind of stars like light stars. This means that unlike exoplanets, brown dwarfs emit their own heat and light. It's much less than that of stars, obviously, but we can detect it directly, especially in the infrared wavelengths in which James Webb Telescope specializes. The observations obtained by a team led by astronomer Brittany Miles of University of California, Santa Cruz, are from a brown dwarf some 72 light years away, called VHS 1256-1257b, first described in 2015. It clocks in at around 19 times the mass of Jupiter and is relatively young with a reddish hue atmosphere. The hue has previously been attributed to clouds in young brown dwarfs, so the team took infrared spectra to see if they could determine the brown dwarf's composition. This works because different elements absorb and re-emit light at different wavelengths. Scientists can look at the spectrum to see dimmer and brighter features and determine the elements that cause them. The atmospheric composition of VHS 1256-1257b was similar, the team found, to other brown dwarfs studied in infrared wavelengths, but much clearer. Water, methane, carbon monoxide, carbon dioxide, sodium and potassium are observed in several portions of James Webb spectral based on comparisons from template brown dwarf spectra, molecular opacities, and atmospheric models, the researchers write. The carbon monoxide feature, the researcher says, is the clearest seen yet, and they also detected, as they hoped, clouds, long hypothesized clouds of silicate particles in the thick layer with a sub-micron grain size. These are likely minerals such as phosphorite, enstatite, or quartz, the team said. This seems to finally confirm that young brown dwarfs can be circled by patchy silicate clouds that influence variability in brightness. This gives us a tool for interpreting observations of brown dwarfs in the future and something to look at for future observations, a researcher said. These initial results from James Webb Telescope early release science observations are groundbreaking and also obtainable for numerous other nearby brown dwarfs that will be observed in future observation cycles. This observatory will be a trailblazer pushing our understanding of atmospheric physics in planetary companions, brown dwarfs, and exoplanets for years to come, they said. This has been submitted to AAS Journal, available on ARXIV, and this is on Collective Spark. by Michelle Starr Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.